All right, so I just want to do a little rehash of yesterday for our communal benefit and also for the benefit of the new folks. This can be short or long. Really, what I want to do is I just have 2 slides, and I would like it to be a discussion. So I'll put some material on the table, and then you guys jump in and tell everyone else how you see it, if that's okay. Okay, so we heard from Michael and Sham yesterday a little bit about the old and new view in economics, or what I'm calling the old and new view. In the old view, we have this sort of microscopic world and the macroscopic world, the aggregate. And basically, we have more or less assumption of kind of perfect information processing, stable prefs, and behavior in accordance with a well-defined utility function. So rational actors. And in the new view, we've got imperfect info, right? Limited or biased cognition, which is one of the biggest themes of this week, and unstable prefs, right? Also, we learned that we need to pay a little bit more attention to the environment. It can have complicated structure, and individuals have different windows on it. So there's heterogeneity in the population, and that can be both problematic and very valuable. The social environment has structure with collective effects. So this was a big theme yesterday, both during the day and during the dinner talk of Jim. So there are institutions and rules that structure interactions and behavior. We heard that from Sham, right? So these rules can actually give us markets with equilibrium behavior, even though there's zero intelligence technically in the market. And imperfect information processors with limited or biased, did I already say that? No, I'm sorry. So what's next? Yes, the collective effects. So through the collective effects and diversity, those factors can influence whether the market's efficient and whether there are opportunities that one can take advantage of. Michael talked quite a bit about that. And finally, this idea that really is interesting to me came up both during the day and during Jim's talk, which is that in some cases for the environmental variables we're measuring that are having effects on our agents who are behaving in the market and then generating these aggregate properties, there's a ground truth, like the jelly beans in the jar. We can count them, the height of the Eiffel Tower. And in other cases, it seems like the aggregate properties describing the system are really the result of collective dynamics or collective perception. And those, the collective perception poses a lot of challenges for understanding that process by which we go from the microscopic to the macroscopic, how information is aggregated. All right, so this problem of having a good measure of efficiency. So that actually raises a sort of more general issue about the role of physics in economics. And so I was reading one of Andy Lowe's papers last week on, I think it's called Physics Envy, something about physics envy is bad for your wealth, that's the title. And the paper was interesting to me mainly because he outlined, he sort of provided a taxonomy of uncertainty and put uncertainty and risk on a continuum. And he had 5 levels of uncertainty, and he said he was suggesting that these different levels of uncertainty are not paid enough attention to in the economics literature. And that's something we in biology think quite a lot about, so that was quite useful. But I was also struck by the beginning of the paper, which is all about physics and why the sort of physics approach in economics has maybe not been a good thing. And he was sort of making this point that I often hear about the sort of premature mathematization of economics. And interestingly, a couple years ago, or actually multiple times over my time at SFI, Murray Gell-Mann, who's the Nobel Prize winner for discovering the quark, would be sitting next to me in seminars, in biology and social science seminars, and he would inevitably whisper during the talk that biology is not ready for mathematics. And when I first heard this, I was quite junior, and I was like, what is he talking about? This is absolutely incorrect. But I came to understand what he meant, and he really wanted a better empirical description of the system before we started applying models. And I don't think he had anything really against the idea that models could be useful as thought experiments, but I think he felt they were being treated as theories prematurely. And I suspect that's to some extent what's meant in economics, but what I tried to point out yesterday in the beginning of my talk is there are other lessons we can learn from physics. And one of those lessons is that the mapping between microscopic and macroscopic is complicated. And in physics, where energy is more important, and in biology and social science, where information processing is more important, that sort of places different demands on how we approach that micro-macro mapping. And I was arguing yesterday that because there's information processing, and I think this actually came up implicitly in this discussion, we need to move between the micro and the macro and really take the data seriously. That the micro-macro mapping in economics and certainly in biology is going to require quite a different approach. And so I presented this slide yesterday, which I'll go over briefly again for the newer people in the room. Okay. So so we're talking about the importance of the environment, so that's represented as W here. These X's are the opinions of the sensors or individuals in the system about the environment. And they all have slightly different windows on the environment, right? Or that's allowed that they all have slightly different windows on the environment. Y's, again, are the simple or quite complicated, potentially, algorithms for aggregating the opinions of X to get your aggregate information, your macroscopic property, so like price or volatility. And Z is the effect of that knowledge, what you can do with it, essentially. So Z are the outputs that are made possible by Y, all right? And so then we have mappings. What's really important, and came up in a number of discussions yesterday, and I'll get to that in a second, are these mappings between these different things. So P is the perception. It maps the state of W, the world, onto the samplers, the opinions X. And A, as the algorithm, is mapping the opinions of X onto these aggregate variables. And this came up quite a bit in Michael's talk, because it's about behavioral economics and how that affects how individuals view the world and translates into behavior. And it also came up in Cade's talk, in which he was emphasizing the role that algorithms might play in helping individuals do better pattern recognition, make better predictions about behavior. And then this was a big part of yesterday's discussion, both during the day and in the evening, in the sense that, as Shan was pointing out, in economics we don't really have a good understanding. Hayek was very interested in this, but we don't really have a good understanding of how this aggregation happens, what this mapping A is, so how X maps into Y and gives us those aggregate variables. We're gaining insight into this process by studying lots of other systems. So in biology, robotic swarms, and so forth, there's lots of work now, and in the wisdom of crowds literature, on different aggregation mechanisms, different ways of surveying the crowd and using that information that's in the crowd, how you can use that information in the crowd to get these aggregate variables. And one thing that came up yesterday that I just want to reiterate is, so we're gaining a lot of insight from the wisdom of crowds literature about, for example, the role of diversity and heterogeneity. But often the aggregation mechanisms that are used to integrate all of that information that's in the crowd are quite simple. So if for example, you take the average opinion. And one question that keeps coming up for me, and I think it's a really essential question, is does that look at all like how the market is computing the information? Or is the market, Michael pointed out that in a complex system, individuals interact, they have, and then there's emergent features, and those emergent features that arise from nonlinear properties of those interactions. And that suggests, if that's the case in the market context, that suggests that the simple mechanisms that we're using to aggregate information in the wisdom of crowds experiments don't map at all, really, onto how markets are doing it. And so even though the wisdom of crowds experiments are giving us lots of insight into why crowds are good and what they can, and how they can get us better information in aggregate, it's not clear that that's necessarily relevant to how the market's doing it. So that's an open question. I think it's one that we should think a bit about. And then B here just maps the behavior of Y, so the aggregate information, onto the output Z. And we talked a little bit about how these sort of common themes in the literature map here. So super forecasters, like Cade, and some Cade's work is about this process. Wisdom of crowds, crowdsourcing is in here. PageRank, that came up yesterday, both in my talk and someone else's. The idea that web search, so often these are PageRank and other algorithms that are used to do web search or measure power, like in monkey groups, as I discussed. These are some of these more complicated consensus formalisms or aggregation mechanisms that can be used to do this mapping and might actually capture how the market's doing the computation a little bit better than the sort of simple wisdom of crowds metrics.